Yeah, hi, welcome back all. So in this lesson, I would like to teach you what's the difference between microprocessor and microcontroller. Let's do some simple analysis. Okay, I think we already discussed about what is microprocessor and where we are using microprocessor, especially in PC. And what is microcontroller? Maybe this term is something new to you. Okay, somebody starting embedded system, okay, completely new. So maybe the microcontroller is something new to you. Microprocessor you're already familiar with. Okay. So in this lesson, we will be we'll be differentiating. Okay, what is microprocessor and what is microcontroller, and what are the different types of microcontroller. Okay, how we are going to classify microcontrollers. Okay, so all these things we'll be looking at, and apart from that, we will be discussing about what are the different types of memory. Okay, what are the different types of memory used in embedded system. So now let's get started. Yeah, so here you can see, like from the image, you can see there is a Intel Pentium processor, microprocessor, and the microcontroller can be anything. It can be Texas Instrument manufactured or NXPs, okay, anything. Now let's see the differences actually. First of all, let's analyze what's a microprocessor. What do you mean by microprocessor? I told already, you can see that inside your PC. So a processor or microprocessor is a small chip, okay, so that reside in computers and other electronic devices. So what is it actually? This chip or this IC is completely manufactured for computing. That's the main purpose of the processor. Okay, so what I mean by the purpose of processor is only computing, then what about the memory? Okay, if I want to do some task, I would like to store the code and I would like to store some other things, maybe the output of the program, or even if I want to interact with some external devices. Okay, so maybe that time, suppose for example, if the processor is interacting with any sensor, and the sensor is actually sensing some physical information. This physical information will be analog in nature. Okay, so like computers can only understand digital data. So the sensors, whatever it is sensing, it will be in analog form. And I would like to convert this to digital. Okay, for that I need a something called ADC, analog to digital converter. If somebody from electronics background, they may be aware about it. If you don't aware, if you haven't heard, just listen right now. There is an A to D converter. It's a separate circuit. Okay, it's a separate circuit or external circuit for like the processor. It will be an IC form. You can get it in an IC form that will be connecting with the microprocessor. I just told one example. So similarly, if I need a external memory, so everything we will be connecting separately with the microprocessor. Maybe you have seen this like in if you want to expand. Right now I think people are not doing that. Maybe when we started using computers, when we were using the old desktops and all, so sometimes we were feeling that the memory is not enough. Maybe the technician used to advise you can connect this external RAM. Okay, so like we used to purchase and connect it, or maybe we are using external memory like hard disk, pen drive, or anything. Okay, to store the data. So that is actually the problem of the processor. Processor mainly like designed for computing, but if you want to do some other operations and all, that is not possible. Only by the processor you will be connecting all the necessary or the required devices externally with the processor. Okay, so then it become a big system, and of course it is more expensive, right? And it's highly complex, right? So I think now it's clear what's a microprocessor. Okay, so microprocessor we can classify as risk processors, CISC, okay, or special processors and all. So RISC means reduced instruction set computer. CISC means complex instruction set computer. We'll see the differences, okay, when we are going to discuss about the microcontroller. So I'll be explain that. What is RISC based? One a simple example I will tell on microcontroller, especially the ARM microcontroller. ARM is actually an architecture. Okay, ARM is an architecture. Using that architecture, several manufacturers are usually making, or they are manufacturing microcontroller. So that architecture the companies are using, and depend as per their requirement, they are manufacturing multiple controllers. Okay, anyway, we were discussing about microprocessors. I think all are clear. All peripherals, all of the required things we will be connecting externally to the microprocessor. So then it become a complete system. And what is microcontroller? Microcontroller, on the other hand, it will be a single chip. Okay, I'll show you anyway. Like in the demo session, we'll be showing the microcontroller. It's not always that the microcontroller will be coming with the development board. Okay, that's just a myth. It will be a simple IC. and all required things will be embedded into that. What I'm saying, all required thing. So little bit of memory will be there, ADC will be there, DAC can be there, okay, IO ports can be there. So what all required for an application to develop at present, so all will be embedded in a small IC. So you can't actually compare the features of a microprocessor and microcontroller. Microprocessor, as I told, that is just designed for computing. On the other hand, microcontroller is designed for some special purposes. What will be the special purposes? For example, I would like to design a remote, okay, or washing machine. Inside that, we will be using microcontroller. Like inside the washing machine, we don't want to use the microprocessor. I'm not going to do any computing over there, right? So we'll be using a microcontroller. And why I'm choosing microcontroller? Like you can imagine the size of a TV remote. It's very small. Okay, so I can't connect all these devices and all externally if I'm using the processor. So on the other hand, we'll be using a controller that is having everything like ready made, but only in some lesser quantity. Okay, so are you getting? I think, is it clear? Yeah, so I hope it's clear. So maybe you can imagine that it's like a ready to occupy space. Okay, everything will be there as per your need. Okay, if you want some more thing, if you want so much of luxury, then you have to like go for some other places. Maybe you have to get it everything your own. So what all the basic needs are there, that will be done or that will be designed within the controller itself. Okay, so many advantages are there, and microcontroller especially, that's the backbone of embedded system, because you know embedded system devices, they're actually dedicated for some special purposes. Okay, even microcontrollers also you can get it in different varieties, on different ways it's getting classified. So at least you can imagine like basic way of classifying, it's like the depend on the number of bit of the controller, and depend the applications we'll be choosing the microcontroller. But in basic microcontrollers and all, I can tell you the program memory size will be lesser. Okay, because see, for example, if I'm writing the AC remote code, that code can't be like so much, right? The number of lines of the code will be lesser, the code size is lesser. So the microcontroller that which I am choosing, for example, it can be an 8051 controller. It's a simple 8-bit controller. So that will be enough to store this 100 lines of code in that. Okay, but on the other hand, if I am actually having a complex program, then accordingly I have to choose the controller. But anyway, I hope all are clear. Okay, so I have everything little bit of there. Okay, so we don't want to connect so many things externally. So that's the benefit of the controller. And here you will be able to see the microcontroller classified with depend on the number of bits. Okay, 8-bit controller, 16-bit controller, 32-bit, and even 64-bit. So 64-bit controllers and all, they're extremely fast. Okay, that even we can use in very complex applications and all. Okay, usually we can use in the like home appliances and all. We'll be able to use 8-bit, 16-bit and all. And 32-bit is a decent microcontroller. So I already like included 32-bit controller in our course, STM32F4. So that's a decent controller. You can use it in the real industry, in robotic applications. Okay. So like the controller which I am introducing is based on ARM architecture. Okay, ARM architecture. All right. So I hope that's clear for all. Now let's talk about microcontroller components. I told everything is inbuilt, right? That just now we discussed. So what all things are inbuilt? So here you will be able to see even inside the microcontroller, there will be a CPU, central processing unit. Okay, so that will be having registers, ALU, interrupt controller, debug, okay, everything. And apart from that, using the buses, okay, it will be communicating with the memory like the RAM and ROM. Flash memory is ROM only, okay, and we'll be having peripherals and ports, input output ports will be there, okay. So little bit of things will be embedded into the microcontroller. We'll actually see some detailed architecture and block diagram of the controllers, whatever we are going to use here. Now we discussed already the microcontrollers like classified based on the number of bits. So that's an important classification. 4-bit, 8-bit, 16 or 32 or 64. Okay. So usually it will be the multiple of 4. Okay. Number of bits in the controller always will be the multiples of 4. And depend on the memory devices, is it embedded memory we are using or external memory we are using, and even using the instruction set, whether it's using CISC instructions or RISC instruction. So 8051 controller, it's a simple 8-bit controller, as I told already, that is based on CISC architecture. On the other hand, the ARM Cortex ARM controller, okay, so that is based on RISC architecture. And apart from that, the memory architecture, is it Harvard or maybe the Princeton architecture, okay, von Neumann and Harvard architecture. So we'll discuss that in short. And depend the family, like who is which company. Okay, so like which category it's coming. It's 801, Motorola, PIC, Texas Instrument, National. Okay, so many companies are manufacturing like one controller itself. That means 8051 one controller only if you're taking, that will be manufactured by Intel, Atmel, okay, Philips, Siemens. Okay, so lots of players are there in the market. So we can choose as per our requirement what controller we need, and from which manufacturer you need. Accordingly, we'll be choosing that. Now let's discuss quickly about some points, some differences between the microprocessor and microcontroller. From this image itself, it's clear that okay, so in microprocessor, like inside the processor, we have only CPU. We are having only CPU. In like CPU consists of ALU, control unit, registers, and all. That's it. Okay, only CPU, and other things are all external. So how we are communicating to this external peripherals or devices and all? So that will be done through the buses. What do you mean by bus here? So bus is actually the transporting lines. Okay, you will call this as address bus. Okay, where you are sending or receiving addresses. Data bus, through where you are actually sending and receiving data, and control bus. So basically, you will be sending the control signals over there. One simple example I will tell you. From one location, I would like to access some data. How can you access the data? So first of all, I will be sharing the location address from where I would like to get the data. So address will be sending through the address bus. Okay. So now after that I will be having a database. Database will be enabled, and through that database I will be receiving some data. Okay. So before that I have to enable the control bus. In control bus I will be giving the signal. Okay, whether I want to read from that location or should I write to that location. So in control bus we'll be sending the control for reading or writing operation. At a time anyway I can choose only one, right? If I am choosing the reading, like a reading signal, if I am sending through the control bus, I will be able to read from the location. Okay, the address which I already got from the address bus. Okay, the address which I passed to the address bus, like from that memory location, I will be able to read something. Similarly, you can do the write operations also. So that's about the buses. Okay. So in microprocessor, everything you have to. That means if you want to interact with any peripherals or like anything, like even IO ports, you have to interact through this buses because everything is external. But on the other hand, you can see in microcontroller, like we are having everything inbuilt, CPU, IO ports, counters, timers, RAM, ROM. Okay. So this is very important. Even the memory is inbuilt in the controller. We don't want to go for the external memory. Yeah, of course we can go. It is very necessary. Maybe if this ROM size is not enough or the RAM size is not enough, then we can expand it. Of course, expansion is possible. For that, like they already, like the manufacturers already added some features and all. So you have to do the configuration accordingly. Then you can get something from the external memory. You can get it something from external memory. It's possible. And one more thing I would like to tell you, I just told already about von Neumann architecture and Harvard architecture. So in von Neumann architecture, the thing is that the program memory, that means the program and data memory, so they will be together. So there will be a pool of memory, program and data, both will get stored over there. There won't be any separation. Okay, so that is about the microprocessor. Why it's possible? Because microprocessors don't have any limitation for the memory and all. They have like big chunk of memory. So program and data, they will get stored together. Okay. On the other hand, if you're looking for the microcontroller, it is based on Harvard architecture. So Harvard architecture is like that. You will be having separate space for the program memory and data memory. They are not mingled together. Okay. So from here, from this diagram itself, you will be able to see clearly it's written inside the controller itself, we are having RAM and ROM. They are separate. RAM stands for random access memory. ROM stands for read-only memory. Usually the program will be there in ROM because we don't want others to alter the code, so that will be in the read-only memory. On the other hand, the data usually will be in RAM, random access memory. Okay, so of course RAM size will be lesser than the ROM size because ROM is going to hold the program, right? So program code size will be like higher. Like in most of the application, in general 100% the code size will be higher, so ROM size will be higher than RAM. And a few other points we will quickly discuss about microprocessor and microcontroller. I'm expecting that all should understand it in detail, then we can start programming. So it will be easy for you. You'll be able to compare or visualize, okay, what's a controller, what I'm talking about controller, what's the difference between a processor and controller. It's all necessary and important things. Okay. And here you can see the microprocessor mainly used to like they are actually used in general system design. Okay, like for example, some complex task if you want to handle, we'll be using microprocessor. On the other hand, microcontroller especially defines for some special purposes, especially in automobiles, like the embedded system we discussed, in home appliances and all. And microprocessors are basic components of personal computer, and microcontrollers are generally used in embedded system. Okay, and computational capacity of microprocessor will be very high. Okay, but on the other hand, the computational capacity of microcontroller will be less. Okay, of course, it's possible in higher controllers and all, but the basic controllers and all not designed for computing, so the computational capacity will be lesser over there. Capacity is lesser in the like in the sense it will take more time for computation. Okay, I'll tell you why it's taking more time. See, for example, if I'm using an 8-bit controller for some arithmetic computation, it's taking more time than a 32-bit controller. Okay, so there is some reason why it's taking more time, but of course it will be able to do, but the like the required time can be like more. Okay, and the microprocessors like that we can use for multiple things, multiple applications we can use. On microcontroller, on the other hand, that will be dedicated or designed for some special purpose. If I program that for the TV remote, I can use it only there, right? Because the program itself will be accordingly. So I'll be able to use it there only. Yeah, so that is okay. So the other things we already designed. So the memory like RAM and ROM, okay, IO ports, everything will be connecting externally to the microcontroller. So the RAM and ROM, everything will be connecting externally to the microprocessor and the microcontroller, it's together. All right, so that's clear. That feature is clear. And one more thing, few more important things I would like to discuss here, like the power consumption. The power consumption in microprocessor, that means in the PC, that's not a problem, right? So most of the time we'll be using that with the 230 volt. Okay, so we'll be using with the power supply, and so power consumption is not a factor over there. Even that we are not considering. Of course, like the battery life, we are actually trying to increase. Okay, once I charge, I should be able to use for 6 hours or 8 hours. So like that requirement is coming from the user, but anyway, that's not a very big deal in microprocessor. But on the other hand, in microcontroller, the power consumption is very crucial. As I told, most of the controlling, like the embedded system devices will be powered with the battery, like the TV remote. I told the example of pacemakers. So every time changing the battery and all not possible. So we'll be using the power consumption method. So there are so many techniques to reduce the power consumption in a microcontroller. We'll discuss it one by one. Okay. We can actually enable the clocks at the required time. So many techniques are there. We'll be discussing in the programming session. And here we can see the microprocessor, the clock frequency is in gigahertz. And the microcontroller will be working with the clock frequency of megahertz. Most probably it will be in megahertz. So you'll be wondering what do you mean by clock frequency and what's the relation between the clock and the microprocessor or microcontroller. So clock basically why we are using. Okay, because we all have clock, right? I think all are having the same time zone. That means like whoever living in a particular country. I'm having a 24-hour clock, so I'm working. Okay, I can't fasten up the clock, right? So I need 30 hours or something. That's not possible. But on the other hand, microcontroller speed you can control depend on the clock. Okay, what are the crystal frequency you are connecting to the processor or controller? You know the relationship between frequency and time period. Frequency is inversely proportional to time period. Okay, so if you are connecting a clock, and means if you are specifying something called clock means its frequency. It will be producing the frequency. So when clock is high, it means to say the time period is less. So higher frequency means you will be expecting lesser time for any operations. Yeah, higher frequency means you will be expecting lesser time for any operations. So the time like will be lesser in the sense, of course, the process will be faster, the operations will be faster. Okay, so that's the idea. So like microcontroller, of course, will be slower than the microprocessor because the clock is only in terms of megahertz. Okay, so it can't be fast like the gigahertz. I think all are clear, right? What is gigahertz and megahertz? Okay, if you don't, just think about it. Okay, just research about it. What is gigahertz and megahertz? Of course, gigahertz is higher than megahertz. All right, so that is one thing. And apart from that, you can see generally microprocessors are not used in real-time system because the reason why it's so, because it's depending on the external components, right? I can't expect everything will happen in a short. Maybe you know like the loading time for the microprocessor, that means the PC, it's more compared to the microcontroller. Why it's so? Even though the PC is having, that means microprocessor is having higher crystal frequency, like higher frequency oscillator or clock we connected, but still the process will be lagging a little bit, the booting process. Why it's so? Because it have to fetch, even though the program is connected externally. That means the program, whatever program we written, Like for the system, right? For the operating system or even for the PC, we must be having a program written, and that program will be storing in the external ROM. Okay. So like you want to fetch it from the external ROM. So this is actually a little bit time consuming. On the other hand, on embedded system devices where it is based on microcontrollers, so even your ROM is inbuilt, ROM, RAM, everything is inbuilt. Okay, so the process, the fetching process can be easy. So that can start quickly without any time. Okay, so that is one important difference. I think now all are clear about microprocessors and microcontrollers. And here you can see typical examples like Intel processor, okay, Intel, IBM, okay, Power PCs. So these are the different example for microprocessors, and microcontrollers we discussed already, 8-bit, 16-bit, 32-bit controller. So in 32-bit controller, even PIC32 is coming, ARM controller is coming, okay. 8-bit controller, it's 8051. I'll try to compare 8-bit controller 8051 and the 32-bit controller ARM processor, ARM processor, because it's always better to compare and study. Okay, it's not mean to say like once you learn the program, see for example, you written the C program. Okay, when you started learning C program, you written a program just to find the sum of two numbers or anything. You written that program in your Windows system. The same program even you can compile it in the Linux based PC, right? So for that you are using different editor, maybe you are using GCC compiler, whatever it is. So there is no major difference in the program, right? So that means you can switch it fastly. If you're a C developer, C++ developer, so irrespective of the processor of your PC, irrespective of the operating system, you are able to switch the system very easily. Adaptation is quick. But on the other hand, microcontroller, there will be some limitation because somebody is completely new to embedded system. Maybe if you are starting with 8-bit controller, I will advise everybody to start with 8-bit controller, the basic controller, understanding all the stuff properly. Then you can go for a 32-bit controller. Okay, so that's how you can go, and you'll be able to compare it and learn what's the difference between 8-bit controller and 8-bit controller, how you will be programmed. For example, how you can actually enable a timer or PWM or anything, or maybe how you can connect an LCD and program that. Then you can come to 32-bit controller. Yeah, I hope now everybody is clear between the differences. Okay, so like what is a microprocessor and what is microcontroller? We have discussed several points, and I already given you like more insight about what is a controller and where we are using and the different applications.